So in this video, we're going to explore in solving quadratic equations, which method would I use? So these are questions that I get often, so I just wanted to go over them with you. So in the first quadratic equation that we're solving here, notice all of them, I'm sorry, I didn't mean to say all of them. This first one, I already have it set equal to 0. So I'm talking about it in the perspective of you've already put it in standard form of a quadratic equation, which is set equal to 0. And in this kind of problem, what this problem I'm going over is, if you notice, b is 0 in this problem. So what do you do in a quadratic equation when b is 0? What's the most efficient way of solving it? And so what I would do is, I would use a square root. Okay, take the square root. So if you only have x squared and you don't have a linear term, bx, that means you can get x squared by itself set equal to a constant value. Okay, that's when you're allowed to use a square root property. So what I would do here is I would add 28 to both sides. I would divide both sides by 3, and I would take the square root. And that would give me plus or minus the square root of 28/3. Okay? Now, number 2 is kind of similar. It's similar in the aspect of the fact that there are 2 terms there. However, the 2 terms that you have are the quadratic term and the linear term. Notice this is in standard form of a quadratic equation. I've had it set equal to 0, okay? This is when c equals 0. Now, you cannot use a square root property method on this, because if you were to take away 7x from both sides, right? Okay? Or I'll even say, let me write it all out. If I subtract 7x from both sides and then I divide by 5, okay, I get x equals plus or minus an unknown. So I never know what x is, because now I have the square root of negative 7x over 5. This is now a variable. This is not. I know what x is. X is this constant value. I do not want x as part of what x equals. That's a no-no. So you do not use the square root property here. What you can do is 2 things. You can either use the quadratic formula, or the quickest way is to factor. If c equals 0 for all quadratic equations you are solving, you will be able to definitely take out a greatest common factor of x. If I factor out an x, I get 5x plus 7, okay, equals 0. Set each linear factor equal to 0. One of my answers is 0, and then I take away 7 on both sides. I get 5x equals negative 7. I divide by 5, and I get x equals negative 7/5. So those are my 2 answers. Whenever you're solving a quadratic, if c equals 0, one of your solutions will always be x equals 0. Okay? You get your 2 solutions here. And the third one, okay, it looks like we have the square of a binomial going on, and we might be able to just take the square root. But the problem here is, okay, I have a square of a binomial, but then I have a non-constant term. I have a linear term. Well, you need to FOIL this out. You need to see all of your terms, because you can't take the square root. So your only other options are, I try and factor, I complete the square, I take the quadratic, I use the quadratic formula. The problem here is you can't use the quadratic formula yet because you don't see all of your terms. Same thing, you could complete the square if you wanted to, but you can't see all of your terms yet. So you have to expand this. You have to see all of your terms. So x minus 1 squared minus 3x equals 1. Okay, so this is x minus 1 times x minus 1 minus 3x equals 1. This is x squared, okay, outer negative 1x, inner negative 1x, that would become negative 2x, negative 1 times negative 1, 1, minus 3x equals 1. Okay, so now I've got all my terms, okay? I don't want to put it equal to 1, never. We always put equal to 0. So first I'll combine my like terms. So that's x squared minus 5x plus 1 equals 1. Okay, and I'll take away 1 from both sides because I always want to set equal to 0. And look at this. It looks like that the easiest way to do this problem, the most efficient way, I mean, could you use the quadratic formula? Sure. A is 1, B is -5, C is 0. But there's a quicker way. If you factor out, there's a greatest common factor of x. This is very similar to this problem here. This is the same as x times x minus 5 equals 0. One of your solutions is 0, and the other solution is what makes x minus 5 0, which is x equals 5. Okay? And so be careful when you are figuring out what type of problem you're solving and which method you are using. Remember, you can't always factor, but you can always complete the square, and you can always use a quadratic formula. You can only use the square root, take the square root, once you have the unknown quantity of x squared set equal to a constant number.